How's everyone doing? Thank you so much for joining this webinar today. My name is Damani Corbin, and today I have the opportunity of sitting down with Raul Jadhav of KubeArmor. He's the creator of KubeArmor, and he was working, the company is called AccuKnox, but KubeArmor is a new sandbox project within the CNCF. Raul, how are you doing?
Doing good. Thank you, Damani Corbin, for having me here. It's looking forward to engaging more with this community.
This is great. This is great. Again, as I mentioned, you have a new project within the CNCF. It's a new sandbox project. Before we get into that, I wanted to get a little bit of background from you as to who you are. A little bit of your experience and just what was that eureka moment that got you to KubeArmor.
So, a brief background about myself. I've been into network and transport protocol optimization for past 20 years. Working in data center technologies, working in IoT and edge technologies. I've been primarily working in the telecom space 10 years before. That's what pretty much my background is. I've been involved in IETF standardization groups where I had special interest on scalable mesh architectures for IoT networks. That is my background, and most of the times what happens is when you work on a network and transport optimizations, security goes hand in hand with those technologies. So that's my security background.
That's interesting. That's interesting. I'm finding a lot more of security and a lot more of traditional network individuals or those profiles of networks or sysadmins of the past are now becoming the leaders in the DevOps space or the leaders in the InfoSec community. What was that eureka moment that led you to KubeArmor? Tell me a little bit more, maybe if you have a few slides or anything to share.
Before going into the slides, maybe let me just take a moment to explain some background about. We started off in July 2020. We had this mutual friend and advisor of ours, Suchakra Sharma. Jehun Nam is the co-creator of KubeArmor. He worked in SRI, Stanford Research Institute, and we three of us were basically discussing what are the best ways to handle runtime security in today's environment. And MITRE attack framework naturally came in front of us, and we saw that in the context of MITRE, there were a lot of mitigation techniques that were mentioned as part of those TTPs, techniques, tactics, and procedures. And we didn't find any clear tool though that could handle those kind of mitigation techniques. Now, a lot of tools could identify the malicious intent and then do a remediation in the sense that go and kill the process. But that is not what we were looking for. So then we decided to do a literature survey, decided to check what are the best options available in Kubernetes. And we found that Kubernetes could make use of certain technologies such as Linux security modules, AppArmor and SLNS. One can specify a pod security context with an AppArmor profile and achieve that goal. Having said that, we found it incredibly hard to deploy these tools directly in the Kubernetes environment. So that made us believe that there is an option, there is a play there wherein if we can bring in something much more simplified and still make use of the security primitives that have been used for past couple of decades, such as Linux security modules, that would be of immense benefit to the community. KubeArmor has been open source right from day one. We started working on it. We did the initial prototype. We found it incredibly useful. So our first goal was to abstract away all the complexities of these Linux security modules, such as AppArmor and SLNX, and provide a simplified layer on top of it, which the DevSecOps team or DevOps team could use to enforce the policies at a granular level. So that was initial idea for KubeArmor. That's how it all started. Let me share a slide, quick, slide about.
Before you share those slides, I think it's really interesting that again, just to mention that this was a project that was collaborated or started with Stanford Research Institute. We're seeing a lot more technologies that are migrating or coming out of educational or research-based institutions to really solve some real-world problems that we're having, especially in this new containerized environment. So I'm happy to see that. Just as a reminder, KubeArmor is a new sandbox project within the CNCF. The CNCF has three stages, if you will: sandbox, incubating, graduating. So this is a new project joined in November of 2021, and we're really excited to learn a little bit more about what AccuKnox is up to and what it's bringing to the cloud native landscape. So Raul, back over to you.
No, thank you for that context. Actually, like I said, our aim with KubeArmor was twofold. One, make sure that some of the technologies that had existed for host-based workload hardening, we could bring the same technologies for pods and containers. How do you do that? The best way to do that was to make use of the same primitives, but apply it at the containerized or pod level. So that is essentially what you see here. You see AppArmor, SLNX. These technologies have existed for past couple of decades. It came around in kernel version 2.4. Since then, it has been there, and it's been hardened over a period of time. Our intention was to make sure that KubeArmor abstracts away the complexities of deploying these security modules, make it consumable in the context of Kubernetes environment. That was our first goal to achieve.
Thank you for the background.
So one more other concept that you'll see mentioned here is the use of eBPF. Again, eBPF has been we have seen more and more eBPF getting used for the policy for not only policy enforcement but for observability. Observability has always been the stronghold for eBPF, but with new hooks added to eBPF and new enforcement points added to eBPF, it is becoming a much more versatile tool to do policy enforcement at the systems level. So BPF.
I'm making a prediction that 2023 is going to be the year of eBPF. I'm hearing a lot more about it, and a lot more technologies utilizing this. So I'm happy that you're educating me a little bit more about the validity of it.
With eBPF, essentially, you don't need to make any changes within the container or pods. You can transparently observe the workloads. Not only observe the workloads, you can transparently enforce the rules without going through, without making any changes to the libraries, SDKs within the application. So that's very powerful. The community, the kernel community around eBPF is also very much driven, in the sense that we can see lot more BPF helpers getting added, new hook points getting added, more simplification getting done to handle eBPF. It was really tough to actually use eBPF in the initial kernel versions when it was launched, but over a period of time with BTF and Cori, we see that the adoption of eBPF is becoming more and more simplified. So naturally, I think that was one of our key strengths in terms of KubeArmor. The approach that we selected, there were two approaches that we selected, we betted on. One was eBPF, and the other was for inline remediation, we made use of Linux security modules. These two approaches have been proven extremely powerful, strong, such that it works in any environment. It works in Kubernetes orchestrated environment. It works in containerized environment. It works on virtual machines and bare metal. So naturally, KubeArmor is able to scale to all such needs.
That's interesting. So it's interesting. A lot more of these infosec or security focused tools. You get in that observability aspect, and I'm spending a lot of time with developers educating that there's a difference between monitoring and observability. When you're monitoring something, you have a clear understanding as to what you're looking for. With an observability solution, you are just taking in information, taking in data, because you're unsure what's going to happen. And many people don't realize the complexities of this new Kubernetes landscape coming from a traditional VM environment, that there's things that's going to happen that you're probably not going to predict. So you need observability solutions and different touch points. And I think that's some of the value that I've been learning that you get at the eBPF level. Bringing that up, can you maybe segue into your CI/CD or your DevOps integration?
That's another interesting angle that you put in, because what we have seen is the two problems with runtime security. It is possible that you can get runtime security handled for a single point in time, but to maintain that security posture over a period of time is really, really difficult. What I mean by that is, let's say, for example, a brilliant security administrator comes up with an AppArmor profile to harden their pods or containerized workloads, but that application is going to change within a few weeks, which means that the whole activity has to be done again by the security administrator. This is extremely difficult to handle with the kind of agile development methodologies that have been adopted across the organizations these days. So it is imperative that the security tools have to move shift left. There is no other way. So with that, one of our key improvements that we did was automating this whole framework, wherein once the workloads are deployed in the CI/CD pipeline, you get observability in the sense of what the workloads are doing. And when the application is updated, you get a differential view. You can see here a sample differential view as to, in version 0.1, there was one behavior of the application. In 0.1.1, the application behavior has changed slightly. This gives the security administrator an understanding of what's changing in the application. And from this information, we are auto-deriving a set of policies, KubeArmor policies, which can then be pushed to the production environment. So that's the move that we are seeing. Customers cannot, deal with the change in the security posture over a period of time. How do the users ensure that the security posture changes, keeps in pace, is in line, is in synchronization with the application updates? It's extremely difficult to do, and you need a strong automation framework for that perspective. The key elements to that is not only the enforcement aspect, but also the observability and making sure that the security posture is automatically derived. So there is one more engine that you might see here. It's called Discovery Engine. And this again is an open source work. It basically consumes the visibility information from KubeArmor across multiple clusters. And it has the ability to auto-derive the workload security posture and the security policies. That's the kind of automation that organizations or users are looking for. We have been getting significant interest for the Discovery Engine as well.
Interesting. I want to clarify that KubeArmor is not an admissions controller, right? Like originally, I was comparing it to Open and Kyverno, and obviously those are leading the pack from an admission controller standpoint. So understanding that it's a different use case, can you talk about the integration that KubeArmor has with admission controllers like OPA or Kyverno?
So the difference here is KubeArmor is a runtime engine in the sense that once the workloads are deployed, it comes into play. Just similar to how network policies operate. Network policies operate once the workloads are actually deployed, and you now can say, allow this ingress packets or allow this egress packets. Similarly, with KubeArmor, you would be able to say, allow this application behavior, allow this application to spawn this set of binary processes, allow these processes to access this set of sensitive file paths, allow these processes to access the network primitives such as TCP sockets and UDP sockets. So it's essentially at the runtime. The way admission controller operates and engines such as Kyverno operates, they basically operate at the admission controller webhook level, which means before the pods are deployed, they'll do a sanity check of whether the containers do not contain any vulnerabilities, the configuration of the Kubernetes manifest is rightly set. It does not make use of any special privileges, but it's pre-deployment stage. What KubeArmor does is essentially post-deployment, once the workload are executing, that's when it comes into play.
That's good. I see that you're utilizing some GitOps methodologies in the process. So I certainly can appreciate that.
That is the way to go. Yeah, that makes things much simpler from DevSecOps perspective, from DevOps perspective, management perspective.
A few years ago, Chick-fil-A came out and mentioned that they're having a Kubernetes cluster at every store, and you're seeing more and more edge use cases. There's, I'm working at Boeing. There's a lot of IoT. There's a lot of disconnected environments. Can you talk to me about, how is KubeArmor integrating for, edge and IoT workloads?
We can see almost in every case that uh, the world is moving towards Kubernetes orchestrated workloads. The same is observed on the edge perspective as well. So we worked with LF Edge, Open Horizon project. We are also working with Intel Smart Edge Open project, where both of these projects are essentially pushing Kubernetes orchestrated workloads to the edge environment. What happens at the edge is, though, one of the primary risks with that approach is that you have multiple vendors pushing their workloads to the edge. How do you ensure the security aspects of the edge? Because if there are multiple vendors pushing their workloads to the edge, if there is a security hole or a gap in one vendor's workload, it should not impact the security of other workloads. For that, you need strong isolation techniques. You need a way for these workloads to not interfere between themselves. KubeArmor provides such kind of container isolation techniques, provides a way for and a security administrator to say that, this container cannot access this set of primitives or assets. So in the context of 5G control plane, let me just give a quick overview. Now, with micro-owners is a Kubernetes-based microservices architecture for 5G control plane. And there is non-real-time and near real-time intelligent controller. What we see is that most of the vendors, the multiple vendors are going to push their workloads or applications that they typically call XApps into this space, which means that as a provider, as a service provider, I need to ensure the security of these XApps. Even if there is a security hole in one of the XApp, it should not impact other XApps. Otherwise, it will be a catastrophe. So how do you do that workload isolation? That's where we are seeing a major play being played. And I believe KubeArmor has a very specific play there. We are seeing a lot of interest for KubeArmor in the edge and 5G control.
That's interesting. That's interesting. I'm also hearing a lot about data on Kubernetes. Can you talk to how you guys are addressing that at all?
When it comes to Kubernetes, your pod is an execution unit. So you have multiple containers within that pod accessing the same volume mount point, but you might, as an application developer, might not have been your intention. So how do you isolate within the containers within the same pod access to those sensitive file system paths? Typically, only a specific container or specific processes within the container requires access to such kind of data. But because of the way in which Kubernetes is designed, you have the whole of the pod having direct access to those kind of assets. If you have customer assets mounted within your pods, you might want to restrict access to those assets, and KubeArmor can provide you how to do that restriction, how to put those constraints in the first place.
Interesting. Thank you so much, Raul. Listen, I would love to see a demo. I mean, if you can give me, not an extensive one, maybe a few 5 minutes or so. Do you have a demo that you can show?
Absolutely. Let me share my screen. Before going into the CLI demo, let me explain you what the demo will look like. And this will pretty much explain you why KubeArmor differs from other policy enforcement engines out there. What I have here is a sample WordPress MySQL deployment. MySQL, as you know, it keeps all its raw tables as part of a specific file system path /warlib MySQL. And any access to this, one of the typical attacks that we have seen is about data exfiltration, wherein an attacker gets into your system and tries to exfiltrate this raw MySQL tables. So essentially, is it possible for us to audit access to /warlib MySQL? When I say audit, it is as well possible to block access to /warlib MySQL outside of specific processes. Like, for example, only MySQLD and MySQL admin would be able to access this file system paths, and everything else outside of it will not be allowed to access. So that's the kind of granularity that is allowed that is possible here. The second is, a lot of times what happens is in the configuration files, the application developers ends up putting authentication token. No one wants that, but that happens more frequently than you would imagine. So even in the case of WordPress application, you can see WordPress configuration file having authentication tokens striven as part of that configuration file. So that is another thing. How do you block access to these kind of configuration files, making sure that only the right application accesses that configuration file? The third is blocking access to the Kubernetes API server. The gateway to Kubernetes API server is a service account token that is mounted by default within the pod. So typically, even if application never uses a service account token, that is by default mounted by the Kubernetes. 9 out of 10 attacks in Kubernetes environment, the attacker in the step 2 or 3 is going to go ahead and look for the service account token so that they can go and do lateral movements across other pods. So this is an important one. Maybe what I'll do is I'll prioritize this particular demo on the CLI. The fourth one is also an interesting one, which talks about blocking execution of specific processes, wherein one example is that in the case of WordPress and MySQL application, by default, the dynamic package management tools such as apt and apt-get are installed as part of container image. Typically, such tools should never be used in the production environment. These tools are okay to be made use of in the staging environment for diagnosis, understanding the symptoms and things like that for debugging purpose. Should never be used in the production environment. But since the same container image is shipped to the production environment, you see these kind of binaries being shipped as part of the container image. So blocking execution of dynamic package management tools is the fourth aspect. So what I'll do is I'll go ahead on the CLI. But before going on to CLI, I'll explain how these policies look like, and that will give you a picture of how simple the policies look like. So these are the 4 policies for these 4 scenarios that I mentioned here. You can see that the kind is KubeArmor policy. So essentially, KubeArmor policies are Kubernetes custom resources are deployed as Kubernetes custom resources. Here you see that the service account token is mounted at a predefined mount point within the pod. And you might want to block access to the service account token altogether, even though Kubernetes mounts it by default. So you can say block access to the Kubernetes service account token. The fourth policy here is the use of binaries. Like I mentioned before, apt and apt-get are dynamic package management tools, and one might not want these kind of tools to be used in the production environment. So how do you block it? So these are the 2 use cases. The second aspect is, these tools, all these policies are can directly be mapped to MITRE ATT&CK framework, the tactics, techniques, and procedures in MITRE ATT&CK frameworks that I mentioned here. I'm going to go to the CLI next to explain how to enforce this policy. What I have here is, this is the place where we'll see all the alerts and violations happening from the workloads. Let me show you what my cluster looks like. So you see this sample application, WordPress and MySQL mentioned here. KubeArmor deploys itself as a daemon set, which means it gets installed on a per worker node basis. Now, I have a set of policies here. The same policies that I'd mentioned before. Let's say I'll take the example of service account token. I have service account token, the same policy that I've mentioned in the slides is mentioned here. Let me log into the WordPress application. I've logged into the WordPress application. Now I'll show you I can access the service account token through a simple binary. Here is the service account token. So here you see I can access the Kubernetes API server and get some information from the Kubernetes API server. What I'm going to do next is apply this policy, wherein all I do is kubectl apply -f. As you can see, it applies at the application WordPress in namespace WordPress MySQL. I apply this policy. You can see the policy as a Kubernetes resource. This is the policy that is applied 5 seconds ago. Now I try to access this token, and you see I'm permission denied here. If I try to do curl, I can see I'm unauthorized to access the service account token. As simple as that. A simple policy like this can prevent access to the service account token. On the right-hand side, what you see is the detailed alert Now, usually when LSMs enforce a policy, they give you information, alerting information in the context of a process, PID, uh, uh, internal kernel details that are mostly not relevant for the security administrator. So your security administrator might need more information, such as what is the container in the context of which this policy violation was observed, what was the namespace. So you can see in this context, the namespace, labels, container details, pods. Interestingly, you can see also which is the Linux security module that was used for policy enforcement. Now, this was about service account token. As you can see how simple it was to apply the policy. I'll go ahead and show the other policy about blocking access to the processes. Again, a simple policy, we want to block access to apt and apt-get. If I run apt and apt-get right now, if I run apt install, it works. It tries to, it will try to download the package. I apply this policy. Now, if I try to access apt install, you see it's permission denied. If I try to do apt-get, the permission is denied. And you can see the corresponding events being shown up here. These events can then be sent to SIMSOR integrations, and the DevSecOps team, the SOC team can wait for such kind of events to check for any malicious intent. That's a quick demo about KubeArmor. As you can see, internally it's making use of Linux security modules and eBPF for knitting this information together. That's the power of KubeArmor. It can do inline remediation in the first place. It can block the malicious intent before it happens. That's a special power.
Raul, listen, thank you so much for sharing. I think this has been very informative. Thank you. I'm excited to see the path for KubeArmor and AccuKnox and what you guys are going to be able to do within the space. Again, my name is Damani Corbin. I've had the opportunity to sit down with Raul here from KubeArmor. They're a new sandbox CNCF project, and I'm just spending time with some exciting projects just to understand how they're going to be able to impact the community. So thank you so much for your time today, and enjoy.